Okay, exercise 508 is finding formulas for optimization. Now, the exercise 509 is on optimization, so this is just a preparation exercise really. So I'm just going to go through 3 different types of questions that you may get. So the first example is 4 smaller squares with side length x centimeters are cut out of the corners of a 60 centimeter square so that it can be folded into a box. Show that the volume of the box is given by this formula here. So here's our square. We've cut x by x out of there, out of here, out of here, and out of here. The whole thing is 60 centimeters. So if we fold along these lines, fold up these 4 pieces, we get a box. So we need to find out the dimensions of the box because we're asked about the volume. So we need to do volume equals length times breadth times height, or length, width, breadth, whatever you want, whatever letters you want to use. So we need to find out the length, the breadth, and the height. So the height of the box would be the x, the length and the breadth would be these sides of the square. So that whole length is 60. So this length here is 60 minus x, or 60 minus 2x. I'll just write it down on that one. It is a square, so they're all the same. 60 minus 2x. So the volume of the box is the length times the breadth times the height of the box. Okay, and if we expand that out, 60 times 60, 3600. It is a perfect square, so we can use the perfect square formula. So minus 2 times that. So 4 6 is 24, 240x plus this term squared, so 4x squared, and that's all times by x. So that equals 3600x minus 240x squared plus 4x cubed as required. Okay, our second example is a cylindrical can. Now this might be, for example, a soft drink can. So it's required to hold 250 ml. First of all, we have to show that the height of the cylinder is 250 pi r squared, where r is the base radius, 250 over pi r squared. Part B, show that the surface area is given by that. So the initial information that we were given here is that it's required to hold 250 ml. So that's the volume, is 250. Remember that 1 cubic centimeter holds 1 mil. So the volume is 250 centimeters cubed. That would hold 250 mil. Now we've got a formula for the volume of a cylinder. The volume of a cylinder is pi r squared h, and that equals 250. If I divide each side by pi r squared, cancel the pi's, cancel the r squares, h equals 250 on pi r squared as required. So that's part A. Part B refers to the surface area of the cylinder. So we need the surface area of a cylinder formula. So the formula is that the surface area equals 2 circles, the top and the bottom, 2 pi r squared, plus the curved surface. Now if you unfold that, you've got a rectangle where we've got a height and we've got the circumference. So circumference is 2 pi r times by the height. So that's our surface area formula. Now what we need to do here is substitute this, our h, into this formula. And this is a common type where you're given information to create 2 formulas and you substitute one into the other. Okay, so 2 pi r squared stays the same, 2 pi r, and instead of h, we're putting in 250 over pi r squared. And we just need to simplify that a little bit. So 2 pi r squared plus, now I can cancel the pi's, I can cancel one of the r's. I've got 2 times 250 on the top, so 500 over, I'm left with an r on the bottom, and that's exactly what we were asked to show. I do have one third example here. So just one more example. Now this one we've been given a diagram. We're told the rectangle PQRS has PQ equals 6 centimeters and QR equals 4 centimeters. A good HSC question will generally tell you exactly what's in the diagram. It said the points T and U lie on the lines SP and SR respectively. So respectively is in the same order, so T is on SP and U is on SR. So that T, Q and U are collinear, they're in a straight line. Let PT equals X and RU equals Y. Pause the video for a minute to have a think about how you might show that XY equals 24. Okay, so basically this type of question is a similarity question. What you should notice is that triangle PTQ is similar to triangle, so that was PTQ, so RQU. And because they're similar, it means that the sides are in the same ratio. So x over 6 equals 4 over y. X over 6 equals 4 over y. Multiply each side by 6y. So cancel the 6's there, cancel the y's there. On this side I've got xy. On that side I've got 24. And that's what we were required to show. Part B, show that the area of triangle TSU is given by this formula. Okay, so this is another one where we're going to have to substitute one formula into the other. We're talking about the area of a triangle. So it's quite simply just area equals half base times height. So the base of the triangle, triangle TSU, so TSU, it's the big triangle here. The base is 6 plus y. And the height of the triangle is 4 plus x. Now, what we can do is we can use this down here as well. You can rearrange it if you want to, but I'm actually going to expand first because there's a neat little thing that happens. So 6 times 4 is 24, 6 times x, y times 4, and y times x. Now, we know that yx or xy is equal to 24. We can directly replace that with a 24. Now, the thing that we have to show only has x's in it, so we need to get rid of any y's. So this y here, we know that xy equals 24, so y is 24 on x. We can replace y with 24 on x. So that's 4 times 24 on x. I am working a little bit backwards here, but I just wanted to really draw attention to those particular things. Okay, so let's simplify all of that. So we've got half. We've got 24 plus 24 is 48. We've got that 6x, and we've got 4 times 24 on x. What's that? 8 and 96 on x. We do want to halve it all, so 24, it probably would have been easier to halve it first actually and then add it up, but that's all right. Plus 3x plus half of 96 is 48 over x, and that's exactly what we were required to find.